founder, Robert, and we pass to the second presentation that is by Tiseo, that is a very good company starting from the University of Genova. The speaker is Renato Zaccaria.
Thank you very much. Thank you for asking us to be here. I try to share. First thing is to share the screen. Okay. Okay. Does it work?
Yes.
Okay. Can you see the slide?
Yes, we can see the slide.
Okay. Okay. Thank you very much. So I will steal your time with just a few slides, 8 slides, to introduce the Tiseo with the content, with the starting from teaching, cultural seedbed. This is the point, the term that I want to point out. So the Tiseo company is a spin-off company that comes from the classical process of technology transfer from researchers and to the market. But also in this case, I think it's really important to understand that is the product of having a community that we call the seed bed, in which young people have been trained to technologies, but not only technologies, but the culture, expanded culture, in particular in robotics and AI. So I think that the topic is also maybe interesting for your project. What we have, I will talk only of the teaching part, so of the degree in robotics and its evolution and the contents of this, and then Alessio, that comes from the cultural seedbed, the young person, will explain the aims and the Tiseo and what is doing. So historically, we started in 2009 with a master in robotics, funded by the first Erasmus Mundus European call, with 3 partners, the École Centrale de Nantes. I think, well, sorry, but I think, okay, I give up with the with the pen. I think it doesn't work so well. The École Centrale de Nantes in France, University of Genoa, the Polytechnical University in Poland, and Asian associated partners, the Jiao Tong University and the Keio University in Japan. In 2009, we started. The idea is that it was of a master degree in which students had to move and spend 1 year in one of the university and another year, the second year, in another university. So not the 3 universities were involved, but the student did choose. Was in advanced robotics, and when it was possible in 2015, it was open also to as a local track, so without the compulsory mobility, single degree, but also with many students coming from outside Italy. So the idea, and so the mobility was also possible, but not compulsory. And last, in 2 years ago, the third step started. So another double degree master started. It's called GEMARO, with the same partners, traditional partners, but also with Keio University. And it took 5 or 6 years to start with this because of the complexity of mixing together the organization and rules and everything of Japanese university and European university. So GEMARO students spend 1 year in Genoa in particular, although in France or in Warsaw, and 2 years in Keio University. So they have 2 degrees, but with, in that case, 1 additional year. The important thing that is very complex to manage, really, is that the double degree, European double degree, Gemaro with Japan, and the local track that we call local, but in any case, we have more than 30% of students coming from abroad. They share courses, labs, organization, and mindset. Well, mindset is important. The idea is that we adhere to international standards, and students are challenged. There is also the ranking of students. So the full mark is not the norm, like in many local situations. And students are encouraged to progress fast since to semester. So in 2 years, they should, or they are pushed to get out. And teaching is based on assignment and continuous assessment. And we always look at international best practices to be aligned with the most important university in the world. And the thesis work is really important. It covers completely the last semester of the track. So to explain how it works, this is the starting point. In general, it was this academic year, September. Gemaro and local students start. Gemaro means that they come from Japan. 1 year. In July, the first academic year is terminated. And so first year, Gemaro students go to Japan, and second year, Imaro double degree in Europe students leave and go to France or Poland. And at the same time, the second year, Imaro students arrive from Warsaw or from France, from ECN. The defense finally is in the August, uncommon in Italy, of the last year, or for local students, but fast students in October. This is the contents, and why I talked about the cultural seedbed. We started with the more classical robotics track with the mechanical courses, automatic control, and some computer engineering, and AI and other additional courses. Today, the program has shifted mostly towards AI, is mostly AI based. Well, the classification of topics is a bit rough, of course, not so well defined, but more or less the mechanical part is still the same. Control is a bit increased, but the AI has increased much, and we will do also in the future, and we expand toward bioengineering. Just to have an idea, just to see the AI, you see, no, sorry, I would like to evidence, okay, artificial intelligence for robotics 1, machine learning for robotics 1, and artificial intelligence for robotics 2 in the first year. In the second year, when there are plenty of courses, small courses just for ECTS, ambient intelligence, social robotics, virtual reality for robotics, cooperative robotics in the middle between the system or the automatic control culture, and machine learning for robotics too, and so on and so forth. And last but not least, linguistics and philosophy of language and psychology of perception and action that is strongly connected to the AI approach. I am just at the end of my short speech. This is an important idea, research track. Research track means that in both the first and second semester of the first year, there are 2 tracks just for working in the labs. To be aware of lab experimental activity, to work on projects or to group projects, learning by doing, and interesting, produce a report closely resembling a scientific paper and discuss publicity. They have speech in front of a broad audience, and the grading of the research track that is compulsory is based on the work done, report, and the discussion in front of the whole board. So that's the end of my speech. I hope that is interesting for you, and is trying to define exactly what I mean with the cultural seedbed. So just to have a group of people interested in investigating new fields of research and possible applications in the market. So thesis is really important. There are individual theses, only one student for it does one thesis, and is connected to research tracks 1 and 2, so that the thesis may be an expansion of topics covered by the research tracks. And before the end of the 3rd semester, the thesis is covered by the full time in the last 4th semester of the 2nd year. And in a course that is called research methodology in the 3rd semester, there is also the designing the thesis, the plan of the thesis, problem definition, literature analysis, and organization of the thesis. So the thesis is very big, and it be defended and ranked in a very strict way. And in general, in the whole tracks, students are pushed to tackle a real world problem. That's the conclusion to linking the presentation of Alessio. Just a figure. We have more than 100 students enrolled in the first year, coming from about 800 applicants. Most part is from Eastern countries, but not Eastern countries. And so the selection is not based on a strict number, but just to have the prerequisites. Just before I forget, you probably have seen in the topics, the artificial intelligence topics, the 2 concepts that I appreciated much that Dr. Alexander has mentioned, of putting, giving a concept of machine learning, so statistical AI, and ontological or symbolic AI. That is one of the points, and probably also Alessio will address. So thank you. Sorry for having stolen some time. I give to, no, I want to close it. Okay. And so please, Alessio, go on with the description of the company.
Thank you very much, Renato. So hello, everyone. I will share my screen with you. Okay, should be this one. All right. Tell me if you can see our slides.
Yes, yes, we can see them.
Thank you. Perfect. All right. So thank you again, Renato. My name is Alessio Capitanelli. I am the product manager of Kibi. That is our product at Teseo. And yeah, today I will try to present to you our activities. I will go fast through who we are, our product, and so on, so that we can leave some space for the technology, which I think will be very interesting to many of you. I see a lot of contacts with what was being said before, And yeah, I think that will be definitely interesting to see together. So what is Teseo? Teseo is a company, a small enterprise, to be honest. We're still in the startup phase in a certain sense, that tries to help caregivers in their everyday activities. And of course, also the people that assist, so older adults and chronic patients, mostly. We design tech solution to support them. And we do this based on our background. So as Renato was saying, our startup is an official spin-off of the University of Genoa, and a very large part of the team, they are either professors or ex-researchers from the University of Genoa. And the team collectively, it has more than, let's say, 15 years of experience in research in the field of mostly ambient assisted living. And that means that the team has competencies in technologies like artificial intelligence, machine learning, IoT, mostly aimed at behavioral analysis. So what we try to do, and we will see later, it's mostly to understand what are the behaviors of the people, how they impact their everyday life. And all this information, of course, they're meant to help caregivers with technologies and solutions that are both effective and easy to use. And that is very important. And we will see why. Anyway, all this experience has led to a number of results in the last few years. Of course, coming from so many years of research, these also resulted in a couple of international patents. We will have a look at them later. And also, we applied all these, let's say, scientific background, not only to our first-party products, but also to some other successful consulting projects in other, let's say, industries beyond healthcare, like, I don't know, like retail sales and so on. The team, very quickly, as I said, don't want to spend a lot of time, but we are mostly technical team. So I was saying before, and as you can see here, all the people that you can see here below, they're all either researcher at University of Genoa, myself included, or they're ex-researchers that they finished their PhD here maybe 1 or 2 years ago. And also in the management team, you will see some, a lot of people that have experience in the academic world. I think everyone except our CEO at the moment has had some sort of research experience in the past. The problem that we are trying to solve as Teseo is, as we were saying before, just to help caregivers. Why is this important? So here you see some newspaper titles from Italy. Sorry, they're in Italian, but the sense is clear. A lot of times when we talk about older adults in Italy and in Europe, or just the Western world in general, is that there are more and more older adults, and that is a problem for a number of reasons. But what we usually don't talk a lot about is about caregivers. Today, only in Europe, there are 100 million that are informal caregivers, so they're taking care of someone at home. And also we have an age dependency ratio that's a measure of how much the older adults population is being supported by the general population. It's already 33% and growing. It will reach around 50%. So what does this mean is that there is a huge part of the population right now that is a caregiver, either professional or an informal caregiver, and that let's say the load, the caregiving load on their life is huge because there are not enough people to support all the older adults or fragile or chronic patients out there. So with technology, a lot of these people, they think they can receive an help. Right now, among professionals, around 40% of professionals, they would like to have some sort of technological aid, either as a cognitive support for their assisted people or telemedicine or remote monitoring, but only 6% of them have found a solution. And if you go to consumer data, that 40%, it gets to 80%. So there is a huge need, a huge gap in the market between what people would like to have and what is really there. And now, I will focus mostly on the professionals during these presentations, but fundamentally what they want to do with technology is to improve the assistance and safety levels, of course. They want to improve the efficiency because, as I told you before, there's a lot of work to be done and not many people or time to do it. And also to improve the retention. So to make sure that the person is happy and that it will stay longer and that it will have, this is highly correlated to the assistance and safety level, of course. But what is blocking a lot in the market, you know, the healthcare market has always been very resistant to technological innovation. But of course, COVID, as it has been said before, also has pushed us probably 10 years faster in the future and faster than we were before. But still, there are a lot of things that are keeping us back as a healthcare industry. And mostly it's the lack of digital skills among doctors, nurses, operators in general, caregivers, and so on. And also the fact that a lot of these systems, you know, healthcare requires many solutions, and these solutions must work together. Today, a lot of the solution in the healthcare space or in the health tech, they are siloed. They don't talk to each other. They are not integrated. All the data are separated. And this is an issue, not just because it limits the potential of the technology, but because it makes using this technology harder for the end user. Because imagine if, you know, in a healthcare facility or in a hospital, and you need to check 10 dashboards, and this data, they just don't communicate. This is impossible to manage. So we try to answer to these needs with Kibi. Kibi, as was saying before, is our main first-party product, and it's an AI platform that helps caregivers to provide personalized and proactive assistance. This is something that we already installed and is currently installed in several partner facilities. And, you know, operators and caregivers in these facilities, they kind of like it. They are mostly impressed with what our actionable insights allow them to do in terms of personalized assistance, of course, but they also enjoy the fact that it's usable and it's simple. So they can access this dashboard, have all sort of data about the people they are assisting. They can offer preventive care. They can react quickly because there are some safety measures integrated in the platform, and I will tell you in a while what they are. And most importantly, I'd say it's very easy to access and share all this information. The features that they are currently in this platform are the following. How do we do what I just said we are doing? Well, we help them know where the people are. There is an automatic fall detection and alert system. So if someone falls down, this is immediately notified. We do, and this is one of the most characteristic features, this sort of behavioral analysis on daily living, on daily activities. So in the healthcare field, there's this concept of activities of daily living that maybe some of you are already familiar, that are literally standard definitions of the activities we all perform during the day, like going to the toilet, drinking, eating, and so on. And these are used to evaluate what is the degree of independence of a person and what are their deficiencies. So these are used really in a lot of assessments, and they're really useful to provide a customized and proactive care. Because if someone is drinking less, for example, and this is very common among older adults because they feel less the sense of thirst, then you can act and probably prevent an hospitalization or any way that this problem leads to other problems. And for all these things that I just said, there is not just a monitoring, that is, I see some data and I report it, but there is also some trend analysis. So we show how this evolved over time. We show if it's increasing, decreasing, if it's in a good range, or if it needs attention. So we take out a lot of the cognitive load from the caregiver or from the operator. And as I was saying before, this is also very interesting. The whole platform is thought to integrate very well with third-party system, being their sensors or being them third-party platforms. So you can think of this as a platform that collects data from a lot of devices, potentially. At the moment, we collect data mostly through smartwatches and environmental sensors that are installed in the environment, very simple ones. But we have projects, and we already did in the past, integrate some third-party sensor like, I don't know, air quality sensors, odor sensor to collect biometric data like smart t-shirts and so on. So really, the system is very flexible, and it allows to collect data from heterogeneous sources and also to send this data to other systems, for example, healthcare record or something like that. I also want to show you some of the work in progress. At the moment, we mainly have two very big work in progress projects. One is we are building our proprietary hardware. As I said before, at the moment, we mostly use smartwatches to collect data, but this is a problem in the, that may be great, especially in some research scenarios, but when you need to build a product, there are a lot of limitations with such a device. It's a general purpose device, so it's very power hungry. You don't have complete control on the hardware and software platform because that is, reliant from some big company, and they're costly because they are general purpose devices. So we're working on a new device that can help us on these sides. And also, this is really more on the research side, is to build a proactive vocal assistant based on the data we collect. So imagine a future where you can take our technology, use it at home, and you can use all the data, the contextual data, we can say, that we collect, like the person is not drinking enough, where it is, what time it is, and so on. And based on that, provide suggestions to the person, and so that you can provide a sort of first help even when the caregiver is not immediately present. So coming back to the example I did before, maybe this lady is drinking less and less because of she's feeling less the thirst, and she's walking through the kitchen, it's around noon. So the proactive vocal assistant, instead of being just a passive actor, understands this context and may suggest, hey, why don't you take a glass of water? And this is really interesting, not just from the artificial intelligence point of view, but also from the user experience design, because this is, uncharted waters, and you really need to design dialogues and ways of interaction that can encourage the person to take, let's say, a positive behavior, but at the same time doesn't annoy the person, because else it will be counterproductive, right? So this was a very quick, let's say, overview of what we are working on and what our system is and what are the devices we use. So now I will take maybe some more 5 minutes just to tell you something about our technology. So if you remember at the beginning, I talked about 2 patents that we registered. The first one, this is the one we will focus the most on today, is the patent that covers Kibi's architecture. So it covers all the systems for data collection and processing and machine learning that we use to provide that sort of service. It has already been granted in Italy and the US, and it's pending in a few other, let's say, geographical areas. And then we also have a second patent. This is very much more recent. It's about localization. I'm sorry for the Italian title here. And what does it mean? I told you before that we also localize the person in the environment using some environmental sensors This is a new technology, a new, let's say, proprietary algorithm that allows to do that only with a smartwatch without relying on any external signal. This is a really interesting thing that we're looking forward to move from research to production at some point in the future. But today we will focus mostly on the core system. So coming to this, I'm sorry about these last few slides. They're in Italian, but I just need a reference from the figures. So bear with me, I'm sorry. So I was saying, this is our main patent, and it covers a bit the whole architecture of Kibi and also all of its functionalities, right? So simplifying a lot, what we did is a general architecture that is very much agnostic from the hardware infrastructure that consumes data coming from heterogeneous system, from heterogeneous hardware and devices, and then process this data, first of all, to classify the data and, let's say, generate a certain number of events. So, for example, we recognize the person is in a certain position, that he did a certain movement, and so on. And then all of these is sent to a huge database that is very much, as we were talking before, sort of ontology or knowledge graph. And on this database, we do some more classical AI reasoning. That's because we want to match all these events that very often, as we will see, they come from, for example, machine learning algorithms or directly from the sensor and so on, into activities. So we do this activity recognition. We generate a context for the person. So what the person is doing, what is, in which environment she is at this time. And then all this data, is exposed through an API. And this API it's used both from, let's say, our client, so you can access from your dashboard and see everything, but you can also push this data to third-party systems. So the whole Kibi system can become a sort of middleware that does all the activity recognition and for you. And you can use this data in a lot of other applications. For example, right now, the data that we generate, they're very interesting, for example, in Alzheimer's disease management, just to give you an example, and so on. Now, I'm moving to a bit more of a detailed scheme of our architecture. This is very simplified, and to be honest, it's not even completely up to date. But the main concept here is that, as I've shown you before, there are three main steps that data goes through in our architecture. That is, data is acquired from the hardware. It's pushed to the cloud, where there are some computation going on, mainly for localization or cleaning data and just a lot of business logic and whatever. And then you go to analyze this data. And this is either, this goes to this machine learning AI engine that I was talking about before that does the actual behavioral analysis. Now, we had some very specific and peculiar, in a sense, requirements for our AI and machine learning subsystem. And that's because, first of all, what we wanted to do was, as I said before, to remove a lot of the cognitive load from caregivers. So it had to provide some sort of actionable insights that were clear and understandable. It also had to be at least partially explainable. We couldn't rely 100% of black box machine learning because that wouldn't be acceptable in our field. And it had to be modular and very easy to scale, because since we do behavioral analysis, and you want to, maybe in the future, you want to recognize a new activity or a new behavior or whatever, and you need to be able to do this easily without, restructuring completely the whole thing. So we eventually landed to a design that are really similar to what was being said before, that combines both classical AI, knowledge graphs, ontologies, whatever, and machine learning. And the semantic knowledge has a very important role because it's, let's say, the uppermost layer of the process. And all of these resulted in our, let's say, proprietary framework for doing this sort of behavioral analysis. To sum up, how does this activity recognition work? What is the process? It's a three-step process, let's say. So, as I said before, we collect data from sensors. This data eventually leads to the generation of some events. So I make you some example. As I said before, the person maybe enters the bathroom or maybe they drink. So we recognize through gesture recognition done in machine learning, the gesture of bringing a glass of water to your mouth, let's say, something like that. Then some of these events, they may, let's say these fundamental event, they can lump together in more complex events. Just to give you another example, maybe you are going to the kitchen, it's around noon, and you are doing this sort of movement that related to drinking, but also to eating. So most probably what you're doing is you're having lunch. And this sort, in some of these more complex events, they eventually are recognized as activities of interest, and so they're shown as, you know, all the parameters that we expose on our system. And the interesting thing here is that this top layer, this contextual, let's say, way of recognizing activity is actually done, as we were saying before, through the use of semantic knowledge systems. So you have low-level let's say, we have machine learning working at the low level because it's just more efficient to do, for example, gesture recognition. But then the actual activity recognition, the actual behavioral analysis, this is done a lot using more traditional semantic knowledge methods because it just makes everything more explainable, more modular. And, you know, also the main, the main drawback of a model-based, semantic knowledge-based approach is that it usually requires it usually requires you to have a model. And that's one of the big drawbacks. Sometimes you don't know the model. But in our case, we do have a model because what we're trying to do, as we were saying before, is to recognize activities of daily living. And those are a very clear definition in the medical literature, in clinical literature. So what we obtain in this way is an activity recognition engine that is able actually to somehow explain why it actually recognizes, for example, a lunch rather than an inactivity or a fall or whatever. And that's because it, let's say, it perceived a certain number of events that are compliant with that pattern that is present in the database, and that itself is based on the clinical literature. On the other side, and that's a slide that shows very well, machine learning is great for the lower level, like gesture analysis and so on. So the main take from these slides, I'm really sorry this is in Italian, is that as we move forward with AI, especially in the health tech, there are no better or worse AI technique. The newer one, machine learning, the older ones, whatever, they all have their role, and it's very important to pick up the methodology that best suits a specific need, and then having these techniques works together. What we see a lot, if I can give you a suggestion, as someone that is working for a startup, is that what we see today, especially in the startup space or in the technology and healthcare space also in particular, is that there is a lot of buzzword and excitement around machine learning. And that's fine. We perfectly understand. We also love machine learning. But that's not the solution to all the problems. So all the AI techniques have a role and a usefulness in building a complex system like this one. And so, well, just a few couple of words more, and then I will quickly finish. So how does
can you conclude in 5 minutes?
Yeah, I'm done.
Thank you.
Yeah, I will just be very, very quick. So I was saying, how do we recognize these events? I was saying before, for example, a drink or something like that, based on machine learning. This is to give you a more concrete example of the first step of this system. Well, we do have a lot of models for any specific activity, for example, walking or eating or drinking. So bringing your arm to your face to just drink a glass of water. And what happens is that you have several machine learning based models that are running in parallel, and then there is a voting system. This is just to smooth out whatever uncertainty there could be. But in this voting system, what is interesting is that you can also take into account some information from the context that is coded inside of the database. So what does it mean is that maybe you have these 4 machine learning models that are trying to understand what you're doing, and 3 out of 4 they say you're drinking. And then there is the context that says, oh, you are in the kitchen and it's around noon. So this is very likely that they're right. And this eventually results in the recognition of one specific event. And yeah, so just to say, this was a final word about, let's say, the technologies that are used. Once these events they are recorded, they're just registered in this huge knowledge graph that allows to do then the automatic reasoning and classification. But yeah, I think my time is over. I will just conclude it here very quickly, and thank you very much for your attention.
There is a time for just a question, one question.
There is one question from the floor here.
Hello, thank you. Thank you so much for the very interesting presentation. In fact, I have many questions, but I will just make only one because my research in PhD was very close to what you are doing right now. I just want to know exactly what kind of data the hardware sensors or the data that are using to recognize the activities. Is it based just on motion sensors, or you are using different kind of sensors to get different kind of data? And of course, this is related to the activities that you are recognizing. It's not clear from the presentation because it's in Italian, in Italy, not in English. But if you refer or you give us some references that we can just go through and look after the presentation. And thank you.
Thank you for the question. Very interesting one. So yeah, I'm sorry about the Italian parts, and also that probably I didn't dedicate enough time to the hardware side of things. So the data we collect is mostly motion data. So of course, on every smartwatch, you have an inertial motion unit that gives you accelerometer, gyroscope, barometer data, magnetic data, and all these data are used depending on the scenario. So for example, when you do gesture recognition, usually we mostly use inertial motion unit data, so accelerometer and gyroscope. When you recognize a different event, like a fall, we do use also data from the barometer, for example, that helps, let's say, filter out some of the false positives that may arise if you only base your calculations on accelerometer and gyroscope. But then, as I was saying before, also the context that is encoded in the knowledge graph is very important. because it helps smooth, it helps again filter out some of the false positives. So you have several models, machine learning models, that are trying to recognize an activity based on the data I was saying before, and they're voting on what is happening. And then you also have a vote from, let's say, the context. So what is happening? What time is it? Where are you? And this also plays a role. And you can imagine this as a sort of virtual sensor, a semantic virtual sensors that just increase or decrease the likelihood that something is happening based on the context. So I don't know if I explained if this answer was clear.
Thank you. Okay. Next presentation is by.
Thank you.
The next presentation is by Ascentius. It will be presented by Marco Siciliano.
Yeah, I don't know why it's not sharing in the screen mode. This way. What's the way I share both?
Yeah, no,
No, it's yeah, probably I had a problem with the connection. Just let me. Yeah. Just let me just a second.
just bear with us for a few minutes.
Here we are. Okay, thank you. Sorry for the delay. I'm really grateful to be here and let's say to talk to you about Accenture. Let's start with introducing myself. My name is Marco Siciliano. As a matter of fact, I'm a past student of University of Genoa. I graduated 18 years ago. What we do for our clients, how we, let's say, shape our services. We have basically 5 practices inside Accenture. The first one is the strategy and consulting, which is, let's say, the more traditional activity we do as a consultancy firm. Let me say that applied intelligence, which is, let's say, the sub-practice involved in all regarding data, is now part of the strategy and consulting. This is an important point because this is significant of the thoughts that to do strategy for level C inside the companies, we need data, we need to deal with data, and let's say also to define the transformation roadmap for our clients led by data. Technology is the practice more focused on the system integration and delivery. We are recognized as a system integrator for main platforms like Oracle, SAP, and Salesforce, and whatever goes on. Interactive is the agency, so very related to the, let's say, design and digital. We mentioned before, my predecessor during this introduction talked about the relationship between artificial intelligence and user experience. If you think about this, it's very important. We cannot, let's say, provide the services. You cannot provide a product which is just technology. You have to think about how this product will serve the final users and design how will improve the user experience for them. We manage operation of our system. We think often about the creation of a product, the setup, but we have to think about the continuous improvement of such products. So this is not, let's say, a path, a journey which ends with the rollout, the final definition of the product. Is something that should be managed over the time and after the final, the first deployment. And the 5 practice, which is the most recent one, is Industry X.0, which is related to the industrial world and more specifically to the IoT. Most of the application of AI is related to information and data collected by IoT platforms. And we think if we think about the introduction of 5G, is even more important because we will be, I would say, surrounded by sensors, no? And this data will become even more important for working on applications. Let's talk about our clients. We normally talk about classify our clients across, again, 5 different market units. The first one is communication, media, and technology. So all companies coming from telecommunication, media, and those companies like Leonardo, Samsung, and so on and so forth, related with technology. My personal experience is very based on communication market because I started over there. I worked for a lot for Win3 and for some time also for DU in Dubai and Vimpelcom in Russia. So I mean, this is my background from the industry point of view. Financial services, so banks, insurance, and financial services in general. Products, which is, let's say, a collection of different sub-markets like automotive, fashion, GDO, great distribution, or life science and pharma. And you know, and we talked about, Robert Alexander talked about the application in pharma and in life science research at the very beginning of this presentation. So this is an emerging market from our perspective. Resources, which is related to energy, and health and public services. Okay, we spend and invest a lot in research. We have labs also here in Italy, in Milan, more specifically in Rome, which serve our clients in order also to co-design the new products and support the prototyping of new products, even in the AI perspective. And we leverage on delivery center here in Italy. They are represented in Naples and Cagliari, but we have even, as you can imagine, even stronger and wider delivery center in India, for instance, and on Center of Competence and Excellence. And the COE for AI here in Italy, established 5 years ago by me personally in Milan, is one of these, this network for delivery center. I was mentioning that Italy is definitely well represented in the global network of Accenture. As you can see, I mean, here in Italy, we have more than 1,000 people working on data and AI. More specifically, as I was mentioning, applied intelligence, which is the practice dealing with the data and the AI, is part of the strategy and consulting, and is focused basically on 4 different streamlines. The first one is data science, so artificial intelligence in general. The second one is about data architecture and data engineering. The third one is related to augmented insight, which is how we present the data and make the data usable by users. So all related to reporting, dashboarding, and let's say data insights. And the fourth, and not less important, is data strategy. We talked about designing a roadmap for the clients in order to figure out how to transform their business, their way to operate in a strategic vision and in a data-led strategy vision. So this is I would say, the first part of an ideal roadmap with our clients, starting with monetizing the data, giving the right value to the data in order to figure out which products, which use case implement with technology. Let me say that we are a consultancy firm, but we are even more and even more focused on the technology. Our CEO, Julie Sweet, is not a technology lady. She's coming from legal, but she's obsessed by technology. And she drove in the last years an important program inside Accenture in order to improve and increase the technology quotient of all people. And she said the last time she'd been here in Milan, over there in Milan, that we need to talk also with the C-level about the technology, and we need to speak about and talk and be able to explain what we do. Okay, so it's just not a matter to show PPT and PowerPoint, but to realize products. Now, we are not a product company. We do not produce products. We provide services and consultancy activities, but over the time, across the project we deliver for our clients, we improve the way we implement these products, and we leverage on assets. So we implemented the platform inside the Accenture, like AIP, which is the Accenture Insight platform, which basically collects all the technology capabilities and services we developed for the clients in order to, let's say, maximize the reuse of these capabilities and the possibility to industrialize the process of implementing new products and projects across the clients. Let me say also that it's very important for us, the partnership and alliance with the technology partners, the big player over the cloud, and of course the AI. I will talk more about this later, but also with the academic network. I mentioned that I was graduated 18 years ago in biomedical engineering, and there was I need to recognize a gap between the university and the enterprise world. But this gap, from my perspective, recently has been, let's say, is going to be reduced, and has been going reduced. People coming from research from university did a lot of stuff that are directly applicable in the enterprise world, basically, and mostly on the AI domain, because the technologies are very open today. There are a lot of open source libraries and products that we mentioned also before, and they are used also in the industrial world. Okay, so this is very important for us. And of course, the relationship with the University of Genoa is particularly important for us. Not only because I'm coming from here. I was mentioning that I can say I founded 5 years ago this Center of Excellence, which is based in Milan and Rome. And as per the numbers showed before, is now counting around 70 guys working on that, with a very different background, coming from STEM faculties, but also from, let's say, they are also psychologists or cognitive scientists and so on and so forth. We are focused, but this is just a representation, on 3 main streamlines. So the first one is about natural language processing, and I'm thinking about concrete application like virtual assistant, text analysis, text mining, the intelligent search in order to look into, let's say, knowledge corpus which are unstructured. Alexander Robert, mentioned that the problem to access information in biomedical application, but not only. No, this is a real great challenge for us, and we worked a lot, and I will mention some example later on this. Computer vision, which is related to advanced optical character recognition. We are in a digital world. Someone says we are in a post-digital world, but the reality is that our company, our life is full of paper, just digitalized. So the automation of the back office, the ability to scan and read documents which are not originally digital, natively digital is really important. Then we have application in computer vision for industrial in the industrial domain. So for instance, analysis of images coming from satellites and drones, the application, of course, in diagnostic in the biomedical fields, and all related to video analytics, also to prevent and maximize the safety within workplaces and not only in the hospitals and so on. The third domain is related to the advanced analytics, so the most modeling oriented part, no? So forecasting, predictive, prescriptive models applied in different domains and industries. We work on, as I was mentioning, on basically all the technologies. We are not coupled or tied or locked in with a specific technology partner. I just mentioned here the big ones, of course, from the cloud, from a cloud perspective and AI perspective. So IBM, Google, Amazon, and Microsoft. But we recently worked with Alibaba. We never talked about Alibaba, which is one of the main providers in the cloud and the AI domain. We worked during the first spread of COVID on their algorithm for the COVID pneumonia detection in TACScan. So again, we are talking and dealing with the application of computer vision in the diagnostic. I'm obsessed personally with the delivery of the project. So as I was mentioning before, when we think about an AI product, we have to look at it in an engineered perspective. It is not just a matter of data science and let's say the core, which is for sure the most important part, no? But we have to think about this product as an integrated product, and we have to face the challenge to implement this product in an engineered wise way. So we cannot deal just with the model, with the statistical problem, with the, let's say, AI focused problem. We have to focus also on the integration, on the implementation of the entire pipeline for the full product. This is the reason why most of the, let's say, technology you look at are not just for libraries for the AI, but are in a full perspective tools which are supporting the system integration of the product in the end-to-end. What we do the delivery, as I was mentioning. We do advisory because many times we start with the client in order, let's say, to provide an advisory about the technology roadmap or the definition of the use case. And we try also to do some awareness and cultures about across our client. I mean, people are increasingly, our clients for first are increasingly prepared and aware about the AI domain, and let's say they have finally a realistic view about and a realistic expectation. But we have also to set up this expectation of talking very concretely about AI, the limitation, the challenges, and the opportunities, of course. So this is also a starting point. Let me say that it is also important to talk about AI in not enterprise-wise domain. So talking in the schools, talking in the communities is even important because AI is increasingly playing a role in our society, no? And topic about, let's say, social responsibility, explainability of AI are increasingly important. We have in mind some drivers to drive to steer the AI project. For sure, the operational efficiency, so the way we implement these products in order to drive more efficiency inside the company. I was talking about the user experience. It's important also to design this product to serve the final user and talk and think about the need from the final users. There is an increasing focus on the compliance. Most of the cost for the company are related to risk management. So improving the automation, improving the reliability of system is even more important than drive automation. Ensuring reliability of process and automation is very important. And of course, data are a fuel for AI, no? So AI is also useful to inspect the data and make emerging new insights from data, and so new patterns and new ideas. This is one of the very last slides, just to say that we started probably 5 years ago with the proof of concept demos and so on and so forth in a not AI industrialized world, but the world is progressing and going faster. So we are looking at AI implementation in at scale and industrialized perspective. So we need to talk also about the frameworks supporting this implementation. It's a matter of use cases. For first, we always start from idea, from creativity. We need the data to fuel the AI. Let me say that we can also produce this fuel, because if we think about the application of generative adversarial neural network and the synthetic data, this is the way to produce new data in order to serve our algorithms. Is a matter of technology, and so choosing the right frameworks, the right enabling also the journey to cloud is a matter of defining the infrastructure supporting our products and the pipeline. So industrialize this process. And when we talk about these pillars with our clients, we introduce also the need for a methodology for adopting the AI, and also drive the reskilling of persons inside the companies. AI is also related to the democratization of access to AI. So not only for data scientists, but for in general, also business use. And AI is modifying the operating model. So how the clients are operating and which are the guidelines and the guidelines and the guardrails they adopt in order to govern and regulate the adoption of the AI. I will conclude with just 3 examples of what we did. This is very related to Genoa and this, let's say, environment, because it's an implementation we did for Gedi, which is one of the main publisher in Italy, and more specifically for a newspaper operating here in Italy. This is a journalist assistant, which basically analyze what the journalist is writing down on the publisher application, and search in the knowledge corpus, so articles from the past, some content which are very related to what is driving, so suggesting contents of relationships and so on. The second one is what we did for Eni Gas e Luce, which is one of the main utilities here in Italy and part of the Eni oil company. And we automatized the back office processes by implementing OCR and natural language processing based technology in order to read the documents sent by customers, okay, and extract information and entities and automatize the overall process. The third one, the final one, is very related to the data science part. This is forecasting applied to drilling in oil for an oil company, Eni, which is a multinational Italian company. And that project has been awarded by Eni as the most innovative project in 2019. And it was really challenging to operate in the industrial world with data coming from the pipelines and the drilling platform in order to predict how to manage some intervention from the control room. So in a very challenging environment. That's it from my side. I hope I did not run out with time. And but if there are any questions, yeah.
But what do you mean by predictive maintenance? Is a maintenance based on the previous profile of failure profile and duration profile of the machine, or
Okay, thank you for your presentation. But my question is, what did you mean by predictive maintenance? It's a maintenance based on the failure curve and deterioration curve of the machine, or it's based on the condition-based maintenance that it's by set up an external sensor and data acquisition on the machine to detect the real-time status of the machine using AI technique.
It's very clear, your question. Most of the time we work on time series and let's say the patterns we recognize in the behavior of these machines. So is a very statistical oriented approach, not most of the time not condition based. Why? Because most of the time, I mean, defining all the conditions for all the type of machine is very complicated. We worked, for instance, for a company operating here in Italy, BS, which produces basically machines in order to cut the wood, glass, and so on. They are rover, which cost, each of them cost, I mean, something like 3,000, 4,000, 100,000 euros. So they are very tailored for the specific needs of their client. So they are very different each other. So you cannot bring there an approach condition-based. You cannot, let's say, design a root cause analysis process, but you have to approach the problem with a statistical approach.
Okay, so it's a prognosis technique. So
Yeah,
it's
exactly.
to determine the RUL of the machine.
Yeah.
Okay, thank you. Thank you.
You're welcome.
Is there other questions? Seems not. Please go.
Yeah, yeah, yeah. There was a question about our presence in the Middle East. Yeah, we are present in Middle East, specifically in Dubai, in Saudi Arabia. We are present in Turkey, of course. There is a strong practice in Turkey, and we are present also in Kuwait.
We have one in Jordan.
Yeah, we have to plan to land in Jordan for sure. This is a great opportunity for us. Agree. Yeah, but I've been for a lot of time in Dubai at the very beginning of my, yeah.
This project has planned some workshop, industrial workshop in Jordan and in Lebanon. So I inform you.
Yeah,
with possible
absolutely
collaboration there.
Thank you for
Okay,
for the room.
thank you again. All the companies that are here. Okay. The next presenter is Daniele Bonventre, that will present us the activities of Algovat.
Yes. Good morning, everyone. I'll try to share my monitor, my screen.
Stop sharing. Stop sharing.
Yes, I think you have to stop sharing because it doesn't allow me to share because someone is already sharing. Okay, just please tell me if you can see something.
Okay.
Yes. Okay, thank you. So good morning, everyone. So let me first thank you for inviting me here. My name is Daniele Bonventre, and I'm a physicist, and I work as a software developer at Algovat in Genoa, which is a company committed in the developing software for green tech solution. And in this presentation, I'm gonna talk about waste management, in particular how artificial intelligence can help supporting and monitoring the process of smart waste management. Sorry. I'm going to show you two use cases in which we are involved. The first is the Scarpino landfill, which is situated in Genoa, Italy, near here, and biodigester plant. So the first case is the Scarpino landfill. First, some context here. What's the main problem in the landfill is the percolation. Percolation in landfill is a problem because rain infiltrating in the waste can dilute and form toxic liquid component that can flow down. This is why the landfill must have a groundwater testing and a storage and a treatment system for percolating liquids. You have to gather all these liquids and make sure they don't end up as a pollutant in the environment. So this is a major problem, and who manage the landfill must be aware and monitor this kind of problem. So in this case study for Scarpino, we ended up building an application which does many things and have to interconnect many parameters and data which comes from different sources. We have piezometers for percolation monitoring. We have inclinometers. We have to detect and control the percolation extraction from well levels. We have to monitor spring water in interception well level. We have a weather station, which gives us a lot of data about weather situation. And we have a robotic topographic station for stability control. We have to make air and water quality monitoring. And also we have to control the percolation tank level and pipeline flow. Because what happens is that rain is flowing through the landfill, and we have to make sure that no pollutants reach the ground and the water system. The Scarpino landfill is covered with layers of soil. It is also required to have a linear drainage layer at the bottom of the pit to prevent the leachate of the liquid from solid waste to sweep through and contaminate water supply. So underground, the landfill is formed by layers of waste, where we have a vertical percolation phenomena, and then these waste layers are covered with soil, and then we have another waste layer. So we have a series of vertical percolation layer, which is made by waste, and the horizontal drainage layer, which is made by soil. At the top, we have the phenomena of runoff, so the rain run on the topsoil and simply flows down. Here I want to show you a graph of what happens after an rain event. For example, in this specific day, we have 30 millimeters of rain event, which is the input signal for us. So we can think it about the input signal, which is this delta signal at the start of the graph. And then we have the response over time, which is, for us, the response is the percolation rate. So how many liquids, how many percolating liquids come at the bottom of arrives at the bottom of the landfill. As you can see, few days after the rain event, the percolation starts growing and then decrease over time. The phenomenon lasts several days, about 60 days. And you can see there is a slow decrease in the percolation rate, but it's not really uniform. You can approach this problem in a predictive stochastic way, which is fundamentally based on analytic solution and analytic formulas, where you put in some parameters, you make some, indeed, a lot of assumption. In this case, as example, it's based on linear mass conservation. We think about water quantity, and it's evaluated using the effective surface of a landfill, the temperature, the conductivity, which also depends on the porosity of the soil. So there are many parameters to take into account, and most of them you have to make some sort of approximation, because the landfill is a huge and complex system, so you cannot really make a precise measurement of all these parameters. You have also to take into account of evapotranspirations, which is the sum of water evaporation and transpiration from a surface area into the atmosphere. Evaporation accounts for the movement of water to the air from sources such as water bodies and, in this case, from the soil. Transpiration accounts from the movement of water within a plant and the subsequent exit of water as a vapor from its leaves, which cover the ground of the landfills. The runoff coefficient is a dimensionless coefficient relating the amount of runoff water to the amount of precipitation received. It is a larger value for areas with low infiltration, and it's a lower value for permeable soil. So there are lots of things to take into account. But once you do it, we've done in this case, you can, what you can out is that the analyzing the system response, you find three main contributions, which correspond to three different from flow rates. Here, the orange line is the response we show before, in few slides before, and then here we can see that it is a sum of three different contributions. And this is very related to the fact that the landfill is underground, it's composed by layer. Water takes some time to reach lower layer, so we have contribution of percolation at different times. So this was one way to find a solution for the problems, but you also can consider the landfill as a black box. So you get rid of all the parameters and all the problems related to their values, and simply use a neural network, artificial intelligence, to model the black box, which is our landfill. There are many problems with the stochastic method, because landfill has semi-open boundary conditions. You don't really know what happens at the boundary of your system or your landfill. It's a complex dynamic system, and dynamics are in evolution. We have indeed a good knowledge of the historical data and a good input precision about rain and weather measurements. So the idea is to use a neural network and model the landfill as a black box. We ignore all the not well-known parameters and simply use the rain as the input of our neural network and the percolation rate as the output. The neural network will do the rest. Here we have the training of our network. We have plotted the training targets, training outputs, which are the raining rate and the percolation rate. Also, we have done some testing, and here we have plotted the response and the real data, which greatly agree in our system. And if we go back to our raining event, here we are real and simulated data comparison. The bars the vertical bars refers to the raining rate measured by the weather station. And the two lines represent the simulated and real data of the percolation measured by the landfill monitoring system. and then the simulated data coming from the output of a neural network. So at the moment, this is a system which we turn it in application, which is installed and running at the Scarpino landfill. So they can use to have a forecast of the percolation, which is useful because you have to treat this percolation liquid in some way. You cannot let them percolate into the ground. So they have tanks where they collect this percolation liquid, and they have to know if tomorrow, in the future, some rain event will occur. They have to know how many percolation liquids they are going to have to manage. The second example, which I'm going to talk about, is a predictive neural system for biodigester management. So first, shortly, what is a biodigester? Biodigester is a green plant which take as input organic waste. Organic waste can come mainly from two sources. The first one is the organic fraction of municipal solid waste. In other words, the organic waste we may produce, let's say, at home. And the other one is the waste coming from, for example, from industry. Let's say from agricultural waste, stuff like that. They are a bit different because organic waste coming from municipal solid waste, it's a little bit different because it has more, let's say, it's not, you have to treat differently because you can find inside more, let's say, pieces of plastic, metal waste, so you have to treat it carefully before going into the biodigester. So organic waste is loaded into the plant. It undergoes some preliminary steps and treatment because you cannot put in the biodigester the raw material. As I said, you first want to remove any inorganic element, such as material, metals, etc. Plastic nowadays is everyday, so you have to be careful. So you have to screen the waste in order to remove those parts. Then waste undergoes an anaerobic digestion, which is a sequence of processes by which microorganisms break down biodegradable materials in absence of oxygen. So it's an anaerobic process. The process begins with bacterial hydrolysis of the input materials. Organic compounds are broken down to soluble derivatives that becomes available for other bacteria. We have acidogenic bacteria. They convert amino acid into carbon dioxide, hydrogen, ammonia, and organic acids. In the acetogenesis phase, bacteria convert this resulting organic acid into acetic acid, amongst other compounds. Finally, we have the methanogenesis bacteria, which convert these products to methane and carbon dioxide. These bacteria are the key of the biodigester plants, and we who manage to take care of the biodigestion plants to make sure not only the system works, but also these bacteria have to stay alive because they are the core of the biodigester. The output of all of these phenomena are in general biogas, which is used to make green electricity energy. but also you have a liquid component coming out via biodigester, which is again, it is treated to make compost, and this compost is used again in agriculture. It's used as fertilizer mainly, and you have at the end a small fraction of solid waste which is sent to again to a landfill, for example. So what are the main problem of biodigester? They want to increase, of course, biogas production, so they have more, they can take more green energy from the organic waste. Also, but also they want to control biogas production. They don't want to produce too much biogas because they want to avoid to burn biogas on torches, because if for some reason they have an surplus of production and they cannot handle it, they have at the end to burn it. So you also want to produce a lot, but you want to produce in a controlled way. And also they are interested in increase the compost production because you use it as a fertilizer or other application. Meanwhile, reducing the solid waste, which have no use. Okay, so we have to make a convergence between environment and digital. We wanted to make an application which can help the management of the biodigester plant in optimizing the energy consumption and the waste production. And also the biodigester have to choose the raw materials they put into the biodigester. So there's also a research about materials, what materials gives more biogas, what materials give us more compost, and what materials also make sure the health of bacteria inside the biodigester is better. There are also a part for cost optimization and maintenance simulation. So our application wants to take it also into account. Okay. So our application, which is called iGreen Digester, is an innovative solution for optimized management of biogas processes, with particular attentions to biophysical components, economical components, and plant management. The application takes as incoming parameters the incoming mix of waste, which is also the input for our neural network. The neural network does not make prediction about the whole process of the plant, but it's making a prediction about the anaerobic biodigester. So from the neural network, we will take prediction about the biogas production, about the liquid components that comes out from the biodigester. These liquids are further transformed in compost and solid waste, and our application make a comparison between the output of the simulation and the theoretical target needed by the biodigester manager. And you can tune the input in a what-if scenario, so you can take a better decision based on the output of our model. So let's say if what if I change the incoming mix of waste? What if I may change some specific parameters on my plans. So the user can have some info about how to handle the system. Our neural network has some fixed input, like the loaded material and the inoculation runs. So how many materials come into the biodigester, but also has a lot of customization parameters. So we build an app so that the users can decide what parameters are the input of the neural network. For example, we have the tank level, the temperature, the mixer, etc. But also you can choose what your output are. The main output can be the waste generated, the biogas, the compost, but also every parameter measured by the SCADA system of the plants can be taken into account. So our interface is able to make the user choose what you want as input, what you want as output, and then train a neural network based on your historical data. We also take into account the fact that your process is not instant, but the input are related to output, but maybe there are some delay between the input and the output.
You have 5 minutes more.
Okay, I will not take some more time. So we ended up to two main solutions. Okay, in choosing to develop our application. One model was what we call the continuous learning method, where the network is retrained every time at a regular time interval in order to include in the training phase the new data and discarding the obsolete one. And then we have the cumulative learning method, where the network is updated from time to time with new data coming from the plant. We ended up choosing for the first method because we made some analysis of the data, and we made some fast Fourier transformation of biogas production. And here we show that we have a very low frequency contribution at omega 0.14, which correspond of a period of 7 days. But also we have a large contribution at a very, very, very low frequency, which corresponds to seasonal cyclical changes. So we cannot use very long period of data to train our network, because the behavior of the biodigester changes over time with annual or, let's say, seasonal frequency. And also, using some correlation analysis, we found that there is a delay, and specifically there is a 1 day delay between the input and the output. So you put your waste in the biodigester, and the output, so the biogas start rising, biogas production start rising the day after. Okay, and this is shown also if you graph the input and the output. Here we have the output in the y axis and the input in the x axis. If you if you take the output, shift about 1 day, you see that the data are less spread, respective to the case with no shift. We have also made some neural network characterization, testing several configuration with different number of neurons in our network, and we found out we don't need really a lot of neurons and layers in our system. And then for the training, we have used 70% of training data set 70% of data set for training and 30% data for testing training. And here we have some results. We have the 120 days of forecast of the simulated output based on a short data set, only 40 days, which is not a big data set, but we starting have a good result. And if you use a longer data set, we had even best result. In this case, we have a comparison from real measurement and real measurement of biogas production and exhaust piston raises, which is liquid coming out from a biodigester. So we have built an application. Indeed, it's a web application, so you can use it using a browser, and we have deployed it in a biodigester here in Italy. And these are actual data coming from these case studies. And in both cases, the landfill and biodigester, we ended up using successfully a neural network for practical use. These are not extremely complicated neural network, but the scope, I think the scope and goal of these projects are useful for also for environment cleaning and management of waste. Sorry, I've tried to make it quick as possible. So if something is not clear, please make any question you want, and thank you for your attention.
Thank you, Daniele.
Thank you.
Any question? Okay, seems no question. So
Okay.
now we have is there one question? Excuse me. No. Okay. Now we have a break of 15 minutes. Thank you.
Thank you.
Okay. Welcome again. We restart the session with a presentation of a company Bees by Alberto Sorrentino.
Okay, thank you. Thank you. First of all, I want to thank Professor Masuli for, giving me the chance to be here today. I'm going to talk about BEES, which is this Bayesian estimation for engineering solutions, which is basically a new startup that we that started a few months ago here in Genova from the mathematics department, and it is a spin-off of the University of Genova. So we had the kind of approval of the university saying that, mainly because what we are trying to do is we are trying to explore the commercial potential of methods that we have been developing first as mathematicians and physicists and computer scientists here in the University of Genoa. So we are a new startup, which is a spin-off of UniG. And so what we do, you can guess from the name, is we try to do Bayesian methods and apply them in any like engineering context we can find. And so in some sense, the first question I asked myself when I was invited is, can we really say we do AI, we do artificial intelligence? And so sorry, I was willing to use this. It worked before the presentation, but now it's no longer working. Let's see if I can do this.
I can't do it.
Well, I can do it otherwise.
This happens all the time.
Yeah. Okay, I will just use this. So no, this is okay. Now it works. So I basically, what I did, I basically went to Google to double check a definition of artificial intelligence, and I found this. So artificial intelligence is the ability of a computer or a robot controlled by a computer to do tasks that are usually done by humans because they require human intelligence and discernment. So this is, I think, a definition we can basically agree on. And this is precisely what we try to do with bees, with our company. So we try to, in some sense, make automation, bring automation in contexts where usually there's a lot of need for human interaction. And I will shortly present an example of what we do. And of course, to do this task, so to do these tasks correctly, so to automate processes that are usually done by humans, you certainly need to use information in the right way. And this is, I mean, what Bayesian methods do. So the Bayesian methods are methods to combine and use information, right? Bayesians, I just do a very short introduction on this. So Bayesians believe that information can be basically represented with probability distributions. And Bayes' theorem is a way to combine information we already have, which is called usually a priori information, with new information coming from the data. And we combine them basically just by multiplying the a priori information, which is a probability density, with another probability density, which is usually called likelihood, and contains the information contained in the data. And just by this product, as you see there, just by this product, we get our posterior distribution, which is kind of the updated knowledge we have on the system. So, and I think this updating of information is exactly what intelligence is supposed to do. So again, I think we do artificial intelligence, even though we usually do not market ourselves with this keyword. So where do Bayesian methods naturally apply? Well, there are two main contexts in which they naturally apply, and they are contexts in which it is important to deal with uncertainty, so with partial information and uncertainty. And clearly one is in the prediction of future events. Future events are uncertain by definition. And so as examples, we can think of patient outcome in some contexts, or also prediction of meteorological events, and or also financial markets. So anytime there is something which is uncertain, we can use probability to track all the possible evolutions of a system, and many other applications, of course. And the second main application field is where we want to do inference under incomplete information. A huge field, for instance, is medical imaging, where we always collect information outside the body to recover information on what happens inside, for instance. But also vision is a problem in where we always have partial information on objects that are constantly hidden behind other objects and so on. And one application which we are working on right now, so I mentioned it just for this reason, is air quality monitoring, where we try to quantify the quality of the air based on some indirect measurements of particles at some given locations, and many other tasks, of course. So just a few words about the company. I told you it's a new startup. So we were born 6 months ago, basically. We are 5 partners. What you see on top is just the year these partners joined the group, but this was a research group basically until a few months ago. And last year, so in 2021, the company started. So right now the organization is very simple. I am the CEO, mainly because I am the only one who was entitled to do it. And we have 1 employee, Gian Vittorio, here. All the other guys are partners right now. Annalisa in particular, she is a researcher at CNR, National Research Council. Sara is a researcher right now at the Department of Mathematics, and Alessandro is a PhD student at the 2nd year here at the Department of Mathematics. So I am a physicist, she's a mathematician, physicist, mathematician. So we are a group of scientists basically that are trying to build a startup. So as we are so young, there's not very much I can really tell you about what we have done so far, but I can describe the context in which we are working and basically the context in which our first contract is happening. And the context is neuroimaging from electro and magnetoencephalography. So I will briefly describe these two tools. So EEG, electroencephalography, is a way to measure the electric potential generated by the brain outside the brain. So it's a set of sensors attached to the scalp. It's a very ancient technique. So basically it dates back to 1 century ago. So the first measurements of electric potential from the brain date back to 1 century ago. It is quite easy to measure EEG, except for people who have a lot of hair. And an EEG instrument is contains between 2, so very few, and 500 sensors. I will say more about this later. That must be attached to the scalp. So that's why hair can be a problem. EEG can cost very little, up to few €100 if you want to buy a basic one, up to very high prices, of course, if you want to buy a fully professional EEG for a hospital. And this is a widely used and widely known instrument. So basically any hospital has an EEG. And the second technique is maybe less known. It's basically the magnetic causing of EEG. So measures the magnetic field rather than the electric potential. This is also relatively old. So the first magnetic measurements from the brain were taken in the 70s. So about almost 50 years ago now. But the problem is that measuring the magnetic field is very difficult because like the Earth magnetic field is billions of times larger than the brain's magnetic field. So what you need is extremely sensitive sensors that are here because they need to stay at very low temperature, close to the zero, basically to zero, absolute zero Kelvin. And you typically need to put this object inside a magnetically shielded room, okay? And the subject can sit here, but he cannot move the head because the sensors are fixed and you have to keep your head inside the helmet in some sense. The helmet then contains, again, a number between 100 and 500 sensors. The whole machine costs a lot, between 1 and 4 million euros, because you have to have the room, magnetically shielded room, and then this instrument is costly. And so, for instance, this is much less widespread than EEG. In Italy, we have only 7 MEGs. But the things are changing a bit. So in the last years, we had a breakthrough in the sensors, basically. So there is this new company which is based in Nottingham, in UK, that produce so-called optically pumped magnetometers. And so we can basically now build MEG, which are like detached. They don't need low temperature, so they can be made in a helmet. You can move around, you can carry it around. And also they can be much closer to the scalp, so you can have much better signal than with other MEGs. And it's even better for EEGs. I think I mentioned that we can have now EEGs with dry electrodes, so no need for paste. And we can have EEG with small number of channels that cost very little, like less than 1,000 euros. So they cost less than an iPhone, okay? So we can monitor brain activity to some degree with very little money. There are many producers now that produce very cheap EEG. There's also an open project called OpenBCI, where you can basically build your own EEG if you have the ability to do it and some time to spend. Now, in this context, what do we do? Now, we work at a mathematical algorithm for going from the measured data, which is something like this. So many sensors, each sensor will measure magnetic field or electric potential in time. We want to go from this to this, so brain activity in time. And now, fundamental feature of these techniques is that they measure this field with a very high temporal resolution. So we are talking about 1,000 hertz. So we have 1,000 pictures of the brain in 1 second of activity. Okay, so it's extremely high temporal resolution. You can do many things with this. What kind of applications do these techniques have? many. One of these is in the context of epilepsy, so it's a clinical application. Epilepsy is basically, well, some types of epilepsy, do not respond to treatment with drugs, and they originate in a small part of the brain, which is kind of responsible for huge electrical currents that are not related to brain activity. And so in these cases, EEG is used to monitor epileptic activity and hopefully to predict the happening of seizures, and sometimes also is used to try and localize the damaged part of the brain. And in some cases, this is then used to remove the damaged part of the brain so that the subject can go seizure-free. Other application, still more related to science in some sense, is the study of functional connectivity. So the study of the brain as a network, as a whole, like how different brain regions interact with each other. And these networks actually change when the subject has some neurodegenerative disease. Okay, so in the context of neurodegenerative disease such as Alzheimer's disease, there's a lot of study going on trying to assess whether it is possible to predict the occurrence of Alzheimer's in advance by using measures of how the brain is connected. Okay, and then there are like more application closer to the real world, like neuromarketing is something that came out maybe in the past decade. And neuromarketing is a combination of neuroscience, marketing, and psychology. And the idea is that you use neuroscience for advertising, for instance. And you can also think of it as neuroscience to decide how to end a movie. Okay, so I know in Hollywood, these techniques are used a lot. Like people are put in a room, they are showed a movie, and then they are showed different endings for the movie. And people look at the brain rather than interviewing the subject to decide which is the best ending for the movie. Okay, and the underlying idea is that the brain will not lie. Okay, so if you look at the brain response and you see like a brain response in the right areas, that means that the subject is happy with the ending or with the product. And the brain will not lie, where the subject can lie for many reasons. And so in some sense, your brain knows you better than you do. So this is the underlying idea of neuromarketing. And then another application, this is kind of a futuristic application in the sense that it's an idea that has been around for a long time now, which is using the brain signals recorded by EEG, for instance, to control external devices. So this field is called brain-computer interface. And so right now, I mean, there are big hopes in this field, I would say, even though it's really difficult. I mean, there are big hopes because there is a lot of information in brain signals, but it is really difficult to control it. So right now, brain-computer interface is based on EEG, can only do very simple things, but there's a lot of ongoing research in this field. So a bit about the methods now. So what we do again is reconstructing brain activity from indirect measurements. And this basically turns out to be an inverse problem, linear inverse problem, in which you have measured data, which is a matrix sensors times number of time points. You have a forward operator, which is a matrix number of sensors times number of voxels. And then you have something you want to reconstruct, which is number of voxels times number of times. So you want to reconstruct this movie of brain activity, which is for every voxel in the brain, you want to reconstruct how strong is the activity in that voxel in time. And well, historically, what happened is that this problem was tackled with regularization methods, which is something which is also very common in machine learning, AI. And regularization, which of course you fit the data with the component, and you also insert some penalty term to induce properties that you want on the solution. And in the 90s, people used Tikhonov regularization, which basically means plain ridge regression in this problem. And the time behavior was not considered at all. So reconstruction was done time by time, independently. Okay. Of course, the brain activity is continuous in time, kind of continuous. So it makes sense to use other forms of regularization. In particular, in the past decade, there was a surge in methods that combine space and time regularization, and these provide solutions that are much better. But still, if you look at something like this, which is like the output of one of these methods, now these activity maps in time, they tend to be complex, difficult to interpret, okay, because there's lot going on, and it's difficult to tell whether this is signal, this is noise, this is something in between. So, and in addition, these methods always need parameters or hyperparameters to be fixed to work properly. So instead, and finally, they are not very accurate in localization. Sorry. And so instead, in many contexts, like neuroscientists or clinicians prefer to use so-called parametric models. Okay, parametric models means that they want an answer like this. They want to say, okay, my brain is active here, here, and here, and like this region has this profile in time. This region has this profile in time, and so on. So let's say low-dimensional parametric models. Okay. And so you want to find a small number of active locations, but you don't know how many locations you want to find, nor where they are. And this is the kind of problem that, I mean, this is how they prefer to look at this problem. And basically, traditionally, this is the way they do it. So they take the signal projected to the helmet, for instance. They handpick a specific time. So there must be a user that says, okay, at this time, I think there is a source. And then they have to manually select a subset of sensors where they think there is a source. Then they start a fitting routine that will find the source. And then once the source has been found, they see where it goes inside the brain, and they need to double check that the location makes sense from a physiological viewpoint. Okay. And so they have found one source with all this process. And then you start over again until you are basically satisfied with the whole result. Okay. So all this process is still done actually in many labs around the world. And this is where we come into play. So basically where we enter. So we basically constructed a hierarchical Bayesian model with probability distributions for all of the variables. So a probability distribution for the number of objects that we want to find, a probability distribution for the location of each of these objects, and a distribution for the time course, so the time behavior of these objects. And once we define, I mean, this is a prior distribution, but then we condition this on the data and we go and approximate the posterior distribution using sequential Monte Carlo techniques. I'm not going to talk about this, but let's say that these are relatively sophisticated algorithms that combine, in some sense, Markov chain Monte Carlo, simulated annealing, and they can be viewed also as genetic algorithms in some sense. Okay, so we use these algorithms to approximate the posterior distribution, and this is basically how the algorithm will work. In this case, it will produce a probability map that will say how probable it is that there is a source in any voxel, and also a probability for the number of objects that we want to reconstruct. And then for each object, we will reconstruct a source time course. So the behavior in time of that source. So this is basically our main product. It's called Sesame, Sequential Semi-Analytic Monte Carlo Estimation, and produces this kind of posterior distributions. So it's completely automatic, like even though now you see like, this is an iterative procedure. So there's a sort of hyperparameter here, which is the number of iterations, but the algorithm knows where to stop. And actually in the last version, it actually combines information from all iterations in a unique posterior distribution. So it basically has no input parameters. It does everything by itself. And so we get very accurate localization, and we also get uncertainty quantification. So we also get information about how certain we are that the source is here, which is important if you need to, use this information to, for instance, operate on the subject, to do surgical operations. Now, this algorithm is actually available open source as a Python code at this address. And so, as I said, this is a task which is previously done, it's still done in many labs by an expert user, and now can be done by a computer algorithm. So in this sense, we think we do AI. Now, from the perspective of a company, what we have been doing so far is we've been collaborating with this company, which is called Beza, so very similar to our name, but it's a different company. Beza is a company based in Munich, and they've been active for 25 years in this field, and they're one of the leaders, maybe the leader in the world for software for EEG data analysis and source imaging. And so basically, our method, Sesame, is now included in Beza research thanks to this collaboration, ongoing collaboration, financed by Beza itself. And we are constantly working at improving and generalizing this method. So what about the business model? Because as I said, we have an open source code. So why do we keep an open source code when we want to sell it? Perfect. Well, actually, this might be a bit, we might be a bit optimistic, but what we think is that these algorithms tend to be complex. And so statistical models are even more complex. So we think it's cheaper to buy them from us than having someone to learn and implement them by themselves. Because of course you can just copy it, but then if you need to modify something, it can get tricky. And so we believe that it's cheaper to buy them from us. And of course, we aim at being constantly ahead of the others. So maybe we don't publish exactly the latest version online, but almost. Just a few words about the fact that I've been talking to you about this problem in neuro brain imaging, but at its core, the problem that we solve is the problem of making inference on an unknown number of objects from indirect data. So the mathematical problem at the core is very, so in many applications, it's the same. So for instance, we have already applied in research context, we have already applied the same method in two other contexts. One is imaging from a satellite. This is a satellite that looks at the sun. And the idea is to make images of solar flares, the big explosions on the sun. And you can represent images of solar flares as superposition of very simple geometrical objects like circles, ellipses, and arcs, basically. And so with our algorithm, we can find how many of these objects we need to do imaging and where to put them. And in a different application, we work with a LiDAR. Maybe you've heard about LiDAR because they are used a lot in automotive context, but LiDAR can also be used to quantify air quality. You shot a LiDAR into the sky, and you measure the backscatter light, and you try to recover the presence of aerosols or particulate in the atmosphere. Okay, and when you want to know what kind of particulate you have, you can have like a very fine or very gross particulate, and you represent this function as a sum of log normal distributions, but you don't know how many components you have, and the same algorithm can be used here to estimate the atmospheric particulate. So to wrap up, to conclude, why should you go Bayesian? Well, why should you not go Bayesian, in my view? Because Bayesian methods can treat complex models. They provide easy to interpret solutions. They provide a full probabilistic assessment of your problem. So not just one solution, but a whole distribution of solutions. And they embody uncertainty in the decision process, which is always the case in many applications. So I kind of think that all artificial intelligence should be Bayesian in some sense. That's it. This is our symbol. Thank you.
Questions? Please come here.
Thank you for your presentation. You say that your EEG system, it's a based on the combination between the traditional SCLAP EEG and resonance magnetic system. My question, what is the advantage of the system concerning the BCI application and the brain connectivity in the side of the diagnosis? Maybe we have some advantage, but in the term of BCI and the brain connectivity, what is the advantage of this system? Okay, thank you.
Yeah, okay, so first of all, we do not have a system here, so we just do the software part.
Okay.
But it's true that it is recently possible to measure magnetic and electric field simultaneously. And there's a big advantage in that because magnetic field and electric field are somehow complementary. So they do not carry exactly the same information. So in particular, there are some sources that you can only see looking at the electric field because they are magnetically silent, and vice versa. There are sources that you can only see in the magnetic field because they are electrically silent. So if you can combine the two, you get more information. And so in general, you get more accurate locations, so better data in general.
Okay, thank you. My second question, there are a toolbox, an open source toolbox for Bayesian in Python and
For Bayesian?
for Bayesian in Python.
Yes.
Okay,
Yes.
very good.
I can give you the others. Okay. Thank you.
Other questions? Other questions? Seems no question. Thank you. The next presentation is by Agostino Bruzzone. He will present his spin-off Scene for Future.
Thank you very much.
Hi.
Can I connect your flash? Good morning, ladies and gentlemen. Let's see, technology. Please director in
Hamrab, so we stop share. This is stop share.
Can I?
Yeah, sure. Left and right. We just share the team.
I feel he's already sharing.
Oh,
You just have to push this one.
okay. Oh, this one. Right.
Activate. Sorry, beg your pardon. The mouse is not more working.
على الماوس. ها الماوس كل الابلكيشن هذا. شايفين الماوس. The mouse is not working. We can't switch to change the share screen. That's it. No, functional mouse. It's not responding.
If you want, I can take my own.
Let's see. It's stuck.
Yes.
Works.
You restart.
No,
No.
bloccato la funzionalità. Several mouse.
Try with another mouse.
Okay.
And maybe interesting.
Yeah, but we can. No.
But when I present, I need the mouse.
Yeah, I will give it back to you.
Okay. The bottle driver, the mouse.
Excuse me, can I,
Yeah, this.
no, if you don't, sorry, I beg your pardon, can you
That's fine.
stop a moment? Just a moment, because if you don't activate it, we never.
It's not work activating, that's the problem.
Ah, okay.
This fix. Oh,
Sorry, let's see.
You can remove
I
that.
removed this one. But I feel I needed to put this back, otherwise it will not work.
Oh, no, this way we can't.
We can work by.
Okay.
Okay, sorry, I apologize for the problem. Okay, I'm Agostino Bezzone. I'm here to present you Sim for Future, that is a spin-off of Genoa University. We deal mostly with use of modeling simulation integrated with other techniques. We work for business application as well as for the sector of defense and homeland security. The team is composed by scientists that have usually, let's say, the large majority, the background in engineering, a different field of engineering. But our experience is in creating models and using even virtual and augmented reality to support operation, business, and industry. Okay. Most of the applications we develop in some way are inspired to a concept of a new discipline where Professor Mazzulli is pretty active in the sector of computational intelligence, that is strategic engineering. The strategic engineering is the idea to combine in closed loop the capability provided by modern data analytics, so capability to extract from data information. But as you know, this is a posteriori approach. So let us to understand what is going or what is gone, but not too much what could be the consequence of decision that we are taking now, with the aspect of simulation that could allow us to check what is the impact of decision that we take, and then to use this all on over them artificial intelligence to take care of supporting data analysis as well as to support carrying out the simulation that are realistic with the stirring parts conducted by intelligent agents, and even to close the loop with the data that come back from the field based on decisions that are taken in order to retune by machine learning the model. And so in this way to create some system that could evolve and support decision. So I don't bother you too much with that, but you can find information. In Genoa, we activated the concept of strategic engineering, first of all, 3 years ago in Master of Science of Engineering, that is currently the largest in the engineering school with over 130 people. And we activated last year an international PhD program that involved already 4 universities in Europe, in Genoa, France, Spain, and Hungary currently, but we are in touch with other countries. The concept is strategic engineering is not to create a strategos. Strategos was once an admiral or a general in the ancient Greek city-state, but to create something that could help a strategos. In the sense of Plato definition, the stratego is somebody that can understand a little better than other what is going and what will happen. And in fact, to take a decision, you need to understand the situation, the past, especially the consequence of your decision. Currently, Sim for Future, as well as the Vega spin-off of Professor Mazzulli, we are both among the patron of this initiative. We have major companies such as Leonardo, Thales, Hitachi, even Accenture that was presenting before us, and we have even several small, medium-sized companies, plus cooperation with major international agencies. So we are even interested, as university, I have the double serving as professor university. The point is that often we use this approach to address new challenge. It's not too much about the defense. Defense respect our business is just a small part. We talk about revenues, probably less than 10% for future. Okay. But it's strategic because usually we carried out quite innovative projects. And in general, this kind of threats could be interesting both for application in business, where a threat maybe is just a competitor, a new product, or something like that. And what else? In general, we was operating in creating simulation models, okay? Different kind of simulations. And one of our peculiarity was the capability to create intelligent agents that could direct entities on the field. Now, if we talk about the sector of defense in wargaming, or if we talk, for instance, about a ship, we have a lot of kind of simulation used to carry out evaluation about how perform a military ship, respect the scenario in a complex scenario, or to train the crew of the ship. But if you talk with any captain, he will tell you that the most critical component of the ship is not air-to-air defense, the cannon, the radar, the sensor, the sonar, but is the crew. It's the crew ability and harmony and skill in operating the ship. So we deal a lot to create and to tune models that are embedded inside intelligent agents to direct this one. So we can create a scenario without putting too many people in the loop, not so many in the loop, but to have intelligent agent that takes the role of these people. Sometimes intelligent agent we use to control a single ship or a plane. Sometimes we carry out to control a position such as SW console or everything. Okay. And another concept we try to emphasize is that one of modeling and simulation, interoperable simulation theory. What it means? Many applications we carried out, our sponsor, the company that sponsorized, or the decision maker could have a great benefit from simulation, but the simulation should be intuitive, should be naturally used, because otherwise they will never use it. If they take an analyst and there is not in closed loop, it will be no payback in time. So this concept is the idea to use solutions that are for serious games. So very easy that you can run eventually on your pocket. For instance, I have not here, but we developed an application to educate and train the manager of company to deal with the new regulation about saving water and water strategy to be adopted in a company, like a serious game that you can play on your smartphone. Okay. But at the same time, we use even the benefit of traditional simulation that have high fidelity and is interoperable, so you can plug and play different kind of models, not really plug and play, but combining in federations, and obviously modeling is fundamental. So I will try to go quite fast on this aspect, but I still have to. So one of the products we developed is what we call AI CGF, Artificial Intelligent Agent Computer Generated Force, that we use to control units in scenarios related to war game or even non-war games, where there are units that don't have a clear assignment. This started as a project, a research project, because when you play a war game or a strategy game, as just a game or a military training simulation, usually we have units that get an order. No? A company or a battalion or a plane, you give an order, you go over there, make a reconnaissance. Okay? You move over there, defend the position. But in a real scenario, there are many entities, in the modern scenario, there are many entities that don't receive any orders, that are, for instance, the civilian. No? But could be just a civilian like us inside his room, or could be a fisherman that is at sea. Now, if you need to find a pirate, the problem is not too much to detect the pirate by the radar, but to discriminate the pirate among fishermen. So if you want to create a challenging scenario for a ship to identify a pirate, you needed to create not only the pirate, but even the fishermen. They don't want to be inspected by the patrol boat of the Turkish Navy. Because if they stop, they will lose hours and hours, even if they are doing nothing wrong. Because they will board, they will make inspections, control, they will lose a lot of time. So you have people that want to escape or some way, that pirate, but are not stupid and don't run away, but try to mix in the fishermen. And you have people that are just fishermen, but want to keep a little bit far, no? As sometimes when we drive and you have a police car, we don't want to be stopped if possible. So you have to discriminate this one. We need to create intelligent agents that could represent that. How we do? By simple rule, and then creating some kind of agent-driven model that could be representative, and by even, let me say, identify and capture the behavior that we recognize from historical data, okay? And this we do, and we embed in AI GGS. The original first application was to simulate evacuation of a village, no? Where you have to send military force to evacuate to save the people. But I will use always this example. If now in this room enter some soldier of Italian army with a flag of Italian army, with an assault rifle, we will find a little bit confused because we are not used to have soldiers inside the university. No? So your reaction is not just to seize a friend or a foe. It's even based on the general context. So we was working in reproducing emotional reaction based on psychology and even based on social aspects. For instance, let's consider this scenario is to about a fire. We need to evacuate this one. There is not too much the fear, but the first reaction is to follow your leader. So if you identify that Franco is where the reference person, he knows his building, and when the alert turn on, he keep quiet, give you clear direction, you will follow, everything will be fine. But if Frank get crazy, get terrified, probably you lose confidence. And necessary sometimes to recreate a realistic scenario to couple this kind of behavior. And this is what we do with the ICGS. We have several applications that we carried out along the time, and that maybe we'll show you something. Malicia was about piracy and smuggling, etc. And we create model about how people communicate, because obviously the communication that influence emotion and social reaction are not just observation direct, but many times now is 90% social, but is even media, radio, what we say by voice. So I have seen something, I tell to you, you tell to your friend tell to his wife, and so on. Okay. Okay. So we can do that for units, just to create more realistic units, like some unit that under fire gets stressed. At some point, maybe don't execute more the orders. Okay. Or vice versa, the opposite. Sometimes under critical condition, the people have a reaction that makes them more strong. No? If they start a fire, somebody gets paralyzed, somebody run away, somebody else gets a lot of adrenaline, so you have a physiological reaction. This kind of model are usually stochastic and include this kind of behavior. Often, in order to model this kind of environment, we use fuzzy modeling, fuzzy allocation metrics that could couple the experience, linguistic experience explained by our experts on the field, with models that are provided by sociologists, or let me say soft behavioral scientists, with the models that they reproduce. And so we create transdisciplinary fields this way. One example that we carried out for our partners was DSIRE. DSIRE is a simulation model that is federate in HLA. You can federate. We carried out in cooperation with MAST and with Genoa University that simulate humanitarian operation. In this case, was applied as South Sudan status, where there was and there is still a quite bad situation that involves war, famine, and so on. Okay. So what is doing that? You can define parameters, and this reproduce the need for carrying out, in this case, mostly food distribution. Okay. That is quite articulate because there are logistic issues that are in some way, let me say, mechanicistic, no? It's mostly distance, time, etc., but with stochastic factor. There are aspects of the insurge, the different party at war that create problems. And there is the problem related to the reaction of population and different parties with the food distribution. So you have constraints that are logistical, constraints that are military, etc. This one is not just a simulator standing by itself, but based on HLA, could be federated with different systems. So you can have a virtual engine that show you, let me say, the event going just to make, let me say, a little bit more cool, or even to get more engaged the players. You have other kind of simulators that could be federated to simulate specific operation. And you have this one that gives the general picture. This gives an idea about IICGS. I give you another example that is bees. I apologize, but I have the same name of the previous company, but it's not related. It's bees 3. This is a project we carried out for a major oil and gas company. That is one of the main producers of FPSO. I don't know if you know what is an FPSO, but are these kind of ships. There are big ships that are re-equipped to be transformed in a production facility that extracts and process gas, oil, etc. at sea. And in this case, the model was applied completely different way respect the previous one. Our goal was to simulate how to reorganize the digitalization of the company. Company had to reorganize their engineering process and their construction process and their acquisition process. So we create models that reproduce each single activities with the constraint of the people in the loop. It was distributed geographically because we have they had the engineering office in Singapore, otherwise in Malaysia, activity of construction in China, in Philippines, in Singapore, on site, direction from Europe, in Switzerland, Holland, and France, and Monte Carlo. So we create this framework and we rethink how we can rearrange it to save. This was a digitalization project already created, but was in a loop, so was not going ahead because of the classical problem in digitalization. What happened was that we used this model to identify the most effective point where to act. Right? So we deal with different kind of applications. We are a partner, as I mentioned, of Strategos. We are a partner even of MIPET, respect industrial plant, so big facility, traditional power plant, iron, steel, water treatment, desalination, where we create scenario related to security and how to protect that are usually critical infrastructure. For instance, we create a simulation that was used to reproduce a potential attack combined cyber and physical by autonomous system that was in 2015, and is public domain now. It is not exactly the replica of the attack that was carried out in Aramco just 3-4 years. A demonstration that we can use this approach in order to be effective on the different ways. Right, I can. Okay, very good. Thank you so much. So I was I need a list to reactivate. Not because now it's okay. Perfect. Thank you so much. So sometimes we develop even the hardware part, or we develop the hardware part with our partner. This is a spider. The spider is a compact cable, quite inexpensive respect to standard. Normally, it would save even compact of around 130 to 100,000 euros. In this case, this cable costs between 40 and 100K, depending on your equipment. 100 if you want to add even motion, vibration, etc. Is interactive in addition to respect the traditional one. It's just 2 meters by 2 meters by 2.5 meters. So we put sometimes inside the container, can be used to make a joint analysis of the scenario. And we use applications in order to evaluate what the scenario that I mentioned about defending a complex that involves power generation for a refinery, desalination, tank farms, etc. As I mentioned, the M2G is strongly emphasizing the importance to create models that could be effectively used by the user. I will provide just a couple of examples. We do research for what we call remote service, remote maintenance. So you have a skid, you have a plant someplace, you can provide both an help, so somebody by a smartphone can go there and see the virtual machine and the real machine and get even support by some kind of troubleshooting. At the same time, we can show remotely on the headquarters the situation to the expert that could direct the person on the field by this kind of software application. Application, as you see, are or in business. This is a project we carried out here in Genoa about evaluating the protection of a new building, respect different potential threats. This building is part of the traditional boat show. We was making a scenario related to an exhibition, a museum with many people moving around, and evaluating what could be, let me say, some kind of combined action that could be, for instance, to provide on that federal level the speaker providing wrong information using fact to block emergency exit, and at the same time to start some fire around and to use some UAV to compromise the aspect related to ventilation system that in this building was the solution to overpass the constraint related to regulation, because it was approved for firefighting, respect performance, not respect rules as it is done correctly. And so in this way, it was very important to test that this performance could be resilient to respect threat. So in this case, we combine different kind of models from NIST, from ourselves, etc., and we recreate a scenario on the ground as well as the cyber space. Sure. Okay. Solid. In terms of service, I already mentioned that we do projects related to the maintenance, for predictive maintenance, but we have carried out even research using machine learning simulation combined way, for instance, for the Navy, in order to identify, based on how cargo move around, so just following their sailing, if they have problems. This is in order to provide to the Navy direction about a ship that could have a maintenance problem, or a ship eventually that deviates from its course because don't want to pass in an area. For instance, I know that is an area there are a boat of immigrants, okay? But if I pass across this area, maybe I will get forced to provide service by the Navy, because if Navy identifies, say, okay, who is the ship nearest to this one? You are a container carrier by mass. Okay, you go there, you take these people. Obviously, this kind of ship are not equipped to carry out this operation. They lose a lot of time, no? And then get blocked because it's not classical rescue operation. Classical rescue operation, you take the person that are on the wreck, and then at the first port you arrive, if your destination is Rotterdam, you drop at Rotterdam. But in this case, based on the United Nations direction, maybe they say, no, stop. You need to go back to Naples, no? So it will be unfair. So sometimes these ships communicate in some way and say, okay, if this is an area that is danger, we'll deviate. Observing this kind of behavior, the Navy could identify something they don't see directly, but see as indirect observation. For the Navy, it's not too much for immigrants, it is not critical, because critical in this sense, because immigrants want to be detected. So to detect immigrants is not a big deal. Can anticipate, but doesn't change. But for instance, it's very interesting to detect smuggling. Because if I have strange to sail off to ship, etc., I can have a red alert. Obviously, it's not a solution, but a solution where you have the situation, let me say, south of Mediterranean, the area in front of Sicily, you have literally thousands of contacts. You can get much less alert to concentrate your analysis. So you can reduce false alert, you can identify aspects, you can anticipate. Before to get a request for support, you can anticipate. Another project by Safe for Future was PACE. PACE was about combining data from socials, data from sensors, etc., to make a forecast about how many people can go. This was a main initial proposal that we submitted. We was even talking with Professor Masulli in order to provide a direction to the town administration when they organize that. And then we have Janus. Janus simulation that we carried out for consulting is a software that makes you play a simple game where you are responsible, a consultant, junior consultant, and needed to interview, let me say, 4 major responsibles. The responsible of the marketing, let me say, control, management control, ID information, ECT department, and human resources. And you have some kind of very simple interaction with them. So you pose question, get a reply. Based this reply, you should understand what is the status of the project for digitalization of the company. Company may be changing the software, introducing a CRP, introducing a PDM or CRP. And so you needed to identify. This was devoted initially to just, let me say, train the junior consultant, but we make an experiment. We couple this with an artificial neural net. The artificial neural net was used to make ourselves an assessment of what was the situation at the time. So it was allowing you to play the game in a random environment and in some kind of activity intelligence that could give you an evaluation of your performance. But the idea, but it's not yet finalized, is to use on the computer of the junior consultant as a support when they make the interview to give some alert of the situation. There are several of these projects that we carried out. I mentioned just the last one before to close. I feel I have 2 minutes. This is a project which is quite active currently. We are working in Germany, in other countries. This is a system that predicts the most, or that support the definition of most effective promotion in the retail sector for major companies. So what is those? Use artificial nets, neural nets to capture and to identify some reliable forecast about the sales. Use some kind of simulator to identify how changing the promotion, because when you promote something in a week or in 2 weeks, you have to change the following week, you have a regulation, you have a promotion at, let me say, national level, from the quarter, you have promotion on just one region or sub-region of the area. So it can allow you to auto-remix this one with simulation, see what happens, and use a genetic algorithm to carry out an optimization to find out the most promising mix. So you can use that in order to guide you. At the same time, at that center, you have the person, the decision maker, that could use each of the different modules independently, because maybe I give you my proposal, but maybe you want to change and test yourself, or so you test by simulation, or you want to redo the optimization, injecting some your solution as an elite to see if it generates new ones, or you want to reanalyze and reforecast some specific product with a different aggregation logic. So this, I feel, provide you an overview of what we are doing. Is mostly about the use of, let me say, modern simulation in combination with computational intelligence. Questions? Just a comment. Thank you. Just a comment. Thank you. For this presentation. I'm amazed how many different things that you are able to tackle with this new team. Thank you. No, thank you so much. In fact, we were emphasizing to create a module to be reusable. For instance, several of these applications that I mentioned, where you needed to play, for instance, the opponent, but there are not too much the opponent, I explained it. There are mostly the, let me say, the other that create your scenario was made in a way to be easily readapted from, obviously, when we passed from fishermen to people to evacuate, we had to work. But in many of these cases, we have research projects that was supporting us for the opportunity to involve other people that have a specific experience or in the context or operational. Normally, we try to create a team that compose operational people, in the case of evacuation firefighter, and people that are maybe behavioral scientists that are, I don't know, so behavioral psychologists or sociology. Okay, thank you very much. Thank you. Oh, okay. Well done. Okay. So, yeah, sure. I take in my, you have to connect this.
Presentation. So the mine is just one. So I have to share my screen. Share screen. Okay. Okay. Even my research group has produced, generated a startup spin-off company of the University of Genova that is called Vega, the Star Vega, that is the Objective Research Laboratories. Okay, it was founded 4 years ago, and the operational location is a lab inside this building. The owner are myself, Stefano Rovetta, and Alberto Cabri, people that is here already know them. And also there is another company that acquired a quarter of the property. Okay, our skills start from machine learning to many other related technologies, and the mission of the company is the support to customer to introduce artificial intelligence in their companies. Okay, obviously our knowledge starts from the mathematics, and but with the collaboration of some for example, some students or PhD students or postdoc and other professionists, we are able to arrive to give it to the customer a system completely working. Okay, we had the application in Industry 4.0 that now is changing the name to 5.0, Industry 5.0. Where human-centric sustainability and resiliency are stressed. Okay. One of the first application we done was the optimization of the make to stock with respect to make to order. So we have we had a data set that we use for training a neural network. Yesterday, Alberto showed in details this approach. The success is good because at the first run of the neural networks, we obtain a good classification of with high accuracy, 96%. The rest of the work to be done is very limited. Another application that is the bot detection in websites, though the web robots or bots are programs that live on the web, and sometimes are focused, for example, to change the evaluation of restaurants, hotels, etc. Or sometimes when they are malicious, they arrive to complete an order on Amazon, maybe. So the problem is to detect. They made some artificial clicks, like the one with the dose we do with the mouse. But the behavior is completely different from the human behavior. So in few clicks, our system is able to detect them with good efficiency. After few requests, you see on the graph, after 2 requests, we are able to arrive to the distinction of 85%. And but in 5 requests, 5 clicks, we are able, usually we obtain 100% of accuracy. The technique is implemented with neural networks. They are able to detect, to classify the single click and the single sequence of click, and a probabilistic integrator that is an old technique that works very well. Okay, we use the same technique for prognostic maintenance. And in this case, we done this work in Bradford, where we have a strong connection with the University of Bradford in UK, in the Automotive Research Center. And the results are very useful. The last project, the last new project, one of the last new projects that our company is dealing with is the application of machine vision, computer vision to circular economy. The idea is to classify with efficiency the different components, electronic components that are on the electronic boards that goes to the waste. From if we are able to sort capacitor different kinds, resistor, etc., for each group of them, we can perform a mechanical chemical extraction of metal with very high efficiency. So the problem of we perform intelligence recycle. And so this is a result on the image of a board. We have the 2 different classes of components. Then we use the AI on the edge using Jetson Nano. The work is done with those 3 design stages. There is the problem of sub-images labeling. So we take a number, about 100 of images of board, and manually we classify, we included in rectangles the different kind of components and giving them the label. After that, on the server with a stronger GPU, we implemented a deep neural network model using YOLO, that is a strong package for deep learning. And then the model we obtain can be uploaded on the Jetson Nano, and the running is quite good. So here we see a video of the same experiment, or similar experiment we done yesterday in this room. Okay, you see that the classification is good. You can imagine a robot that can extract the different components. The results are stable even if the board is rotated. Okay. for the smart city, we are at this moment, we have close to Port Antico in the road that is posed upper the level of the normal street. We have some cameras that are they are seeing the close to the entrance of Port Antico, where there are not these pedestrian only for security, and two other cameras are in a little bit on the west, and there is possible to perform both security then traffic monitoring. To the in addition to the camera, we add some simple audio sensors that was designed by us. And so you see those the small Raspberry here side and two MESM sensors and audio sensors. And each day we receive, in our server receives 21 gigabyte of data. They are not information, but from there we extract a few kilobytes concerning relevant events in correlation with the images that come from the cameras. This is the system, the physical system. There are a lamp with LEDs, so it's cheaper for energy consumption. That is equipped with the cameras, and also here there is our box, this box. Okay, here we have also applied YOLO for car detection. That it works very well. Also in this movie we have also the detection of people. There are smaller square rectangles that are posed on people. You have to wait for. Okay, now there is this white car is turning, and inside it we can see the driver, the square corresponding to the driver. Okay, we in the past we implement a model for traffic flow forecasting using neural networks, and this model could be combined with the previous traffic flow detection. We also collaborate with the companies making shoes for the optimal nesting. That means the optimal position of the shapes that are necessary for making shoes on the leather, with the main object of reducing waste, but also to take in account possible holes, so low quality parts of the leather, and also take in account for the color nuance and the texture. So the cost function can be defined with those constraints, and we can obtain optimize it using, for example, particle swarm optimization that is used also by Agostino. That is okay. So this is a possible solution of a problem. Another application neural networks we done was the optimization of the crew of a ship. So it's very real important that the ship and the team inside it must be well qualified. So each people inside the crew has a specific duty, and the replacement must be at the same level. So the companies, the the resource management companies for the naval field have a list of 10,000 or more possible substitutions that each day can change as evaluation. And the neural network help to make this selection very quick. Okay, another application we are starting now is the application of many kind of sensors to guide the operator in the welding procedure when we have a very large welding, very large shape of metal to be welded. So the problem is not simple. We have to apply many algorithms of computer vision, but the application is viable. Okay. Another activity we done in the last 20 years so also is application of artificial intelligence to health. So the reason why I have a connection with Robert Alexander. So one application was related to the detection of cancer from MRI images. And this was done through deep neural networks. We work also in genomic data classification. And moreover, we have developed many apps connected to web server for supporting people with chronic diseases, for example, diabetes. And in this case, the data coming from the glucose meter are collected and sent to a server where we can perform data analysis, data analytics. There are many issues that can be combined. For example, the food diary, the activity motor that could be activity data that can be collected using wearable sensors. And for example, we can predict glycemic crisis and also give different kind of support through vocal assistant, for example, so give information to the patient, support to calculate the quantity of insulin to inject, etc. Another application that is done with the hospital of San Martino Hospital that is close to the bus stop where you arrived. So is the monitoring of IDASH, of migraine. So this is another aspect. So the patient keep track the IDASH and indicate the possible symptoms and intensity, etc. So the data are sent to the server and analyzed by the medical staff. Okay, then we have also developed a tracker, very cheap tracker, based on the webcam, for example, the webcam of my laptop and some neural networks. So the the observer must put his face on the oval that is drawn on the screen. Then the face is recognized, the position of eyes are recognized, and the direction of the eyes is measured. Those three levels are done by neural networks. If you put this couple of images on the screen, a face and a cup of coffee, a young boy, preschool boy with autism will prefer the cup of coffee, even he doesn't drink coffee, because he tried to avoid the gaze of another people or the face and the gaze. So this is an index of autism. So we are going to make experimentation with, in collaboration with psychologists. And the last result I'd like to present is VEIT, that is a visual and auditory training app for cognitive recovery. The idea is to present on the cell phone a simple piano scale, a keyboard with a scale do, re, etc. And the program will start playing two notes selected at random. The task is for you is to reproduce this sequence. That is easy. If you are able, the number to do that with the 2 keys, the number of keys that are played by the program will become 3. You have to reproduce, and so you go forward. When you arrive to 5 keys, the problem is not easy. Not easy. When you arrive to 7, it's very complex, because they are played at random. They are not an harmony. They are sounds, or only sounds. So this is a limit of our perceptual system. People with some problems renounce after 3-4 notes. So the idea is to measure the cognitive capability, but even it's possible to modify the program in order to train you. So if I fall, you start to have a error, to make errors with 4 notes. So for 2 notes is okay, 3 notes is okay, 4 notes, I make some mistake. The test with the 4 notes is repeated sometime. So the idea is to go down to 3 notes and make exercise, a long exercise. Sometime after this exercise, I go to the level of 4 notes, and after some test, I am successful. I can go to 5 notes, etc. This program works, and it's possible to give to the user both channel, auditory and visual, or even only the visual channel, or also only the auditory channel. So this is the idea of cognitive improvement. I think is all.
Thank you, Francesco, for this presentation. Any questions? Sure.
My question regarding the applications, are they started here in the, like, as for students, for master or PhD students as a research thesis or dissertation, or they are applied research for?
Depends. Sometimes, for example, most, yes. Okay, depends. For example, the application, the health field at present are started from project with the students, and so they are not the TRL, the technical level. Technical level is 2 or 3 They are only demo. Instead, the application in industry we done, they are a real product. So the TRL is at least 5.
Most of the research is just for research, not for to solve some problems. That's a problem. Many research. So are they linked to the industry? So they are doing this research on demand or just?
Okay, yes, for the application, for example, to the true optimization is with a contract with a company. The application on the project on circular economy is is given by European project as a company, not as a university. Those applications, the health, could become real products, but at present are only demo because it's not easy to interact with the pharmas.
Francesco, I think this is the end of this meeting and this visit. Now I'd like to thank you and thank University of Genoa and thank all your colleagues who have participated in during these 3 days. I thank you for your generosity in time and for the richness of the program that you have organized and successfully run during these 3 days. These 3 days were a great eye-openers for us. There were a lot of projects and we're very satisfied with the information that we have received. We are happy that we have visited Genoa and met you in person, and I hope that we continue collaborating in this project and see you in Jordan and Lebanon in the near future. Thank you very much.
And thank you and all the colleagues coming from Lebanon and from Jordania, because in this period it's very difficult to move abroad. I am very happy, and my group is very happy to collaborate with the project, and we will be happy to come in your countries and for continuation of this project, and also sharing students for projects for inside the project, etc. Okay, thank you.
We have a photo.
Yeah, the last photo, yeah, last picture. Yes, stop sharing. Stop sharing.